So today we'll look at problem 19 of the MIT Integration B qualifying exam 2017. The indefinite integral of e to the power 2x times cosine 3x. Certainly a very interesting problem. But yeah, let's just see how we may be able to solve it. So this is our problem, right? The indefinite integral of e to the x cosine 3x. One thing I would like to do is I would like to equate this integral as I. And then I may be able to go ahead and say, okay, e to the 2x is the same as the derivative. And I mean, since these functions are kind of cyclical, I could choose whatever I want to begin with, but let me choose to use e to the power 2x and express this as the derivative of e to the power a half e to the power 2x times cosine 3x, right? And then now we can use integration by parts, where we said if you have a function that consists of a product of a function v and the derivative of a function u, when you integrate that, we have the product of u and v minus the integral of u and the derivative of v. So this is an important integration by part formula that we'll go ahead and use. So since we say that our problem is now the derivative of a half e to 2x cosine 3x, right? And this being u, this being v. So uv is going to be a half e to x cosine 3x minus a half e to the 2x. The derivative of cosine 3x is what is it? It is negative 3 sine 3x. So which is equals to, and by the way, we say this is a half, so we have we say this is I is equals to a half e to the 2x cosine 3x, and this negative comes out. We have 3 over 2 e to x sine 3x. And then we continue again and we say, okay, this is the same as a half e to x cosine 3x plus 3 over 2 times the derivative of a half e to x sine 3x. So as we said, I is equals to a half of e to the 2x cosine 3x plus 3 over 2 integral derivative of a half e to the x sine 3x. Using integration by parts again, so we have so here we have a half e to x sine 3x minus a half e to x, derivative of sine 3x, we have 3 times cosine 3x dx. So this is the same as a half e to x cosine 3x plus 3 over 2. bracket I have e 2x sine 3x, and we're going to pull this 3 out, so we have 3 over 2 integral of e to the 2x cosine 3x, and we see that this is the same as I. So our I is equals to a half e to the power 2x cosine 3x plus 3/4 e to x sine 3x. This times that, we get 9 over 2 over 4 rather I, and we want to bring that this side, so we have I plus 9 over 4I is equals to a half e to the x cosine 3x plus 3/4 e to the 2x sine 3x. So this becomes 4I plus, so we have 13 I over 4 is equals to that. So I is equals to 4 over 13 a half e to the x cosine 3x plus 3/4 e to the x sine 3x. Okay, so that's where we've gotten. So we've come to a point where we have I is equals to 4 over 13 in bracket, we have a half e to the 2x cosine 3x plus 3/4 e to the 2x sine 3x. We can pull the common values out, and so we can have 1 over 13 e to the 2x, and 4 times a half becomes 2 cosine 3x, and then 4 times 3/4 becomes 3 sine 3x. And so what we learn from our problem is that the integral of e to the power 2x cosine 3x is the same as 1 over 13 e to the 2x 2 cosine 3x plus 3 sine 3x plus the integration constant, and that is our answer. So thank you so much for your attention. I hope you enjoyed this process. Until next time, bye bye.